Hey Algebra 1, here is your notes for 10.1, your intro to quadratic functions and graphing. Now we've already talked a little bit about these, but not explicitly. We haven't identified them as quadratic functions yet. So I'm starting up here. Rock music managers handle publicity and other business issues for the artists they manage. One group's manager has found that based on past concerts, the predicted income for a performance is modeled by that equation, where X is the price per ticket in dollars. Now, why does this graph make sense? Well, you would think that the more that tickets cost, the more that their profits would increase. Why at this point up here do we suddenly see a decrease in the graph? Well, let me ask you this. If something costs you $20 for a concert ticket, that's not awful. We see something costs $40 for a concert ticket, that's not awful. But when you get up to $16.80, that is a lot of money to be paying for one concert ticket. So it makes sense because at some point or another, people don't want to pay that much. So the tickets become too expensive. And people don't want to pay anymore. They just stop, they decrease their sales. We have a similar situation going on over here. Cliff divers often do a lot of calculations involving quadratic functions to ensure their safety. You may not believe it, but it is true. You'll notice if they start on the cliff, it's not just a direct linear piece down into the water. There's often a little bit of a curve. And this curve is modeled by a quadratic function. Right here you can see that. Notice how wherever he starts, that's his constant. Just something to notice. All right, let's hop down. So what do quadratic functions look like and how do we graph them? Well, the first thing that you're going to see in every quadratic is this term, the a times x squared, where a is just that coefficient, just that number out in front. We call that first term the quadratic term because it involves the x squared. The next piece we have is the linear term. And notice, if I get rid of this quadratic term, I have a y equals mx plus b situation, and this is just a line. So if I take away the quadratic, I have a linear. So that's why this is called the linear term. Now, if I take away both the quadratic and the linear term here, all I have left is the constant term. And that constant term turns our line into a constant function, so something that is just a horizontal line. So there's your constant term. The graph of any quadratic function is called a parabola. And I'm going to be using this word more and more, so let's get used to using that when we talk about it. So how do we graph these parabolas now that we kind of understand what they're used for? Well, we start by finding the vertex, and that's either the maximum or the minimum of the function. Let's jump back up here. Does this graph have a maximum or does it have a minimum? Because there's a maximum point, there's a peak on our graph, this has a maximum. So what you're going to see here is the first thing we need to do is find the vertex. Now, how do we do that? Well, I always suggest creating a table. We'll find the vertex in a minute, but I actually like to make the table first just because it allows me to keep and store all of the information that I've been working with in one specific place. And you don't have to do it my way, but I think it's just a little bit more organized. So I'm going to put my table right here. And we're kind of used to making tables, but it's been a minute. So there's your x and your y. Now let's go back to that vertex. I'm going to introduce a vertex form, and I want you to write this down, and then I want you to highlight it. So any vertex can be found using the formula negative b divided by 2a. And in fact, I would maybe actually put that up here in our little notes area as well. So using this formula, a vertex can be found using the formula negative b over 2a. So that's how we start that. That's what gives us our x value. Excuse me. So where do I get these numbers from? Well, if I go back up to my original equation, you'll notice I have a, b, and c, where a is the number in front of my quadratic, b is the term or the coefficient in front of my linear term. So in this case, there is no number in front of my quadratic term, which means there's just technically a 1. That is my a value according to my function. So wherever I see an a in my form, I'm going to replace it with a 1 because that's what the coefficient is in my equation. The b is going to be the number in front of my linear term. So that in this case is negative 4. So I say negative 4. And that is going to give me my x value when I calculate it. So negative 4 is a positive 4 all over 2 times 1, which is 2. So in this case, my vertex is going to be at positive 2. Now, what do I do with this number once I have it? Well, this is technically an x value. So I'm going to take this value that I found to be the vertex, and I'm going to plug it in for x. Once I do that, I need to find out what my vertex is at y. I know it's going to be on this line. This is going to be my line of symmetry. We'll talk about that in a little bit. And a lot more in Algebra 2. But this is my line of symmetry. But I need to know where or how high up on this line of symmetry my vertex actually is. So what I'm going to do is I'm going to go back to my original equation and say if I want to know what y is, I'm going to plug in x. I'm going to say 2, where x was, minus 2, where x was, minus 4 times 2, plus 1. And when I calculate this, I get 4 squared, which is 4, minus 8. So 4 minus 8 is negative 4. Negative 4 plus 1 is negative 3. So I now know where my vertex is. It's at 2, negative 3, and I can put that on. Now it says 2 values greater than, so to the right of the vertex, and 2 values less than, so to the left of the vertex. So 2 values greater than are going to be 3 and 4. 2 values less than are going to be 1 and 0. Now I do try to usually put my tables in order, but in this case it's a little hard. So I'm just going to keep them out of order for this example. But I'm going to do the exact same thing. All I'm going to do is say if I want to know y, I have to plug in my new x. To find out what's happening at that x value, I need to plug it in. So I'm going to plug in 3 where I saw x, 3 squared, minus 4 outside of 3, plus 1. This is 9 minus 12, which is negative 3 plus 1, which is negative 2. I'm going to do the same thing with 4. Plug 4 in wherever I see x because I'm just trying to find out what's happening at that x value. When I do this, I get 16 minus 16 plus 1. So that's going to be a positive 1. So I'm going to go and say at positive 3, my y value is negative 2. At positive 4, my y value is positive 1. Now, one of the cool things about the vertex and that line of symmetry that I was talking about was that whatever happens on one side of a parabola is going to be symmetrical on the other side. So you'll notice this vertex goes over 1, up 1 on this side of the line of symmetry. Oddly enough, you'll find that when you plug in your numbers over here, we're going to see these dots mirrored over the line of symmetry. So I'm probably going to see 1, negative 2, and 0, 1. Let's find out and see if my prediction was right. So y equals 1 squared minus 4 times 1 plus 1. 1 minus 4 is negative 3, plus 1 is negative 2. Let's see if I was right about my 0 prediction. 0 squared is 0, minus 0, plus 1. I was. So the way to graph these is always to start by making that table. In my opinion, it's just easier because then once you find the vertex, you actually have somewhere to go with it. But we're not quite done graphing it. We do have to connect those dots. And I want to show you how I do this. So maybe it's not so much in how I do it, but what the graph looks like. I start down at this dot and I kind of sketch some dots up to the dots that I have. Once I'm there, I know it's going to keep kind of growing. It doesn't stop at this dot and go straight up. It grows off in that direction. Same thing over here. I'm kind of going to dot it and then I'm going to kind of keep going off. And you can make this line solid, go back and like fill it in. I just like to make the dots when I'm starting because I think it's a little bit easier to graph. So it's a little messy, but you see what that graph looks like. All right, I spent a ton of time on that one. Let's go see some more. So if I graph this function, same thing. I'm going to start with that table, same way we did in the last one. And then I'm going to find the vertex. And remember our vertex formula, I'm going to write it down again, is negative b all over 2a. So in this case, my a is negative 1. My b is negative 2. So I have negative 2. Make sure you put it in parentheses so you don't get mixed up by double negatives. All over 2 times negative 1. This becomes positive 2 over negative 2, or just negative 1. That is my first x value. It's also my axis. Ooh, it'd be nice if you could see, I suppose. It's also going to be my axis of symmetry. So I'm going to go on the x-axis to negative 1. And you don't have to do this either, but I just find that I like to draw a line of symmetry, or maybe a little arrow that says, this is where I'm starting at. This is my starting point. All right, from there, if I want a y value, I have to solve for it. So I'm going to plug in that negative 1. Negative 1 squared minus 2 times negative 1 plus 2. Now I want you to be really careful here. It's been a while since we did PEMDAS, but I want you to remember, PEMDAS says that we must do the exponent first before we multiply, because this negative 1 out in front is technically multiplication. So we need to do exponent first, and negative 1 times negative 1 is positive 1, times a negative out in front. That makes it negative again. Please be careful when you are evaluating these expressions. So I've got a negative 1, negative 2 times negative 1 is positive 2. So negative 1 plus 2 is positive 1. Positive 1 plus your constant is positive 3. So I'm going to go over right away, and I'm going to put that on my function. So negative 1, 3. There is my vertex. All right, from there we want 2 in either direction. So we're going to want a positive 0, 1, and then a negative 2, negative 3. I probably should have rewritten this in order, but I'm not going to. All right, I'm not going to show you the work for all these because I showed you on the previous page, but you're doing the same thing for each. You're still doing y equals for all of these and plugging your numbers back into your original given function. So when I plug in 0, I get 0 squared. Negative 0 squared doesn't really matter. So 0 minus 0 plus 2. When I put in 1, I get 1 squared times negative 1. So that's negative 1. 1 times negative 2 is negative 2. So negative 1 minus 2 is negative 3. Plus 2 is negative 1. When I get halfway done there, I go over just to make sure it's starting to look normal. So I go to 0, 2. Brings back a little bit of your graphing. Do you remember how to graph your coordinate points? Positive 1, negative 1. So I'm going to go over positive 1, negative 1. And then because I'm a math teacher, just like I did on the last one, I like to make predictions. I like to see if there's a way that I will eventually be able to check my work. So I see, because this is the axis of symmetry, that I know whatever happens on this side is going to be mirrored over to this side. So it's one away on this axis. So I'm going to say it's one away over here. I'm just mirroring it over. And again, I would like you to do this in pencil, because if you're wrong, it's easier to change it than in pen. But because I kind of know what I'm doing it in pen. This one's 2 away, so I just go over and mirror it. Now let's see what happens when I plug these back in. Negative 2 squared is 4, times that negative is negative 4. Negative 4 plus positive 4 is 0, plus 2 is 2. So negative 2, positive 2, I already hit one of mine. And then negative 3, when I plug it back in, is positive 9, becomes negative 9, plus 6 is negative 3, plus 2 is negative 1. So I have successfully graphed those dots, negative 3, negative 1. And then we just go back in and sketch based on the points we were given. And try to hit on as much as you can. So now let's look at this a little bit. Let's look at this in comparison to the last side. What impact did this negative in front of my quadratic have on my graph? You'll notice on this one over here, this was a positive quadratic function. What did the graph look like there versus what did the graph look like here when we had a negative quadratic? Well, a negative out in front of the term, when we have something ax squared plus bx plus c. I like to rewrite this so we have practice with it. When your a is positive, so when it's greater than 0, we're going to have an upward graph. So the graph will go up. And if it goes up, it will have a minimum or a maximum. This graph went up. Did it have a minimum at the bottom or a maximum at the top? This one had a minimum. So this will have a minimum. However, if a is less than 0, the graph will go down and it will have a maximum. And I think the easiest way to think of this, my little example over here, is that if you have a negative x squared, that's going to be a sad graph. Negativity is sad. If we have an x squared, that's going to be a happy parabola because positivity is a good thing. So that's my little reminder for you. All right. Let's look at a few unusual examples. So what happens when the vertex is the y-intercept? Well, if I do my quick math here, I do negative b over 2a for my vertex, and I plug things in. Notice I have an a, it's technically just a 1. So I have negative over 2 times 1. But I don't have a b term. This is my constant term. I need the term that has an x attached to it. This doesn't fit my normal function formula. So because there's no b times x, we could technically rewrite this as plus 0x, because then my b would be 0. Now that's still a little problematic because we have negative 0 over 2 times 1, which is just 0. So my vertex is at 0. Well, what does that mean? All it means is that it's on the y-axis. Instead of being left or right, it's right on that middle line, and my axis of symmetry is going to be my y-axis. So let's plug this in quick. If I plug this back into my original equation, I get 0 plus 2. There you go. So I'm going to go 0 plus 2. So that is my vertex right there. Ignore this little dot down here. I was just indicating where the axis of symmetry was. Guess I could create that dash line. There we go. Now I want 2 on either side of it. And this is how I tend to want your tables to look. I know I wasn't putting them in order up here, but if you put your vertex in the middle right away, it's kind of nice because then you can put 2 on either side. So -1, -2, +1, +2. Now let's just plug things in. When I plug in -2, what is it going to kick out? It's going to kick out a 6. When I plug in -1, it kicks out a 3. Again, you know me, I'm halfway done with my table. I'm going to go over and check it out. -2 goes up to +6. -1 goes up to +3. And if this is my axis of symmetry, well, let's see what happens when I mirror it over. I should get 1, 3, and 2, 6. When I plug things back in, I do, in fact, see that my prediction was right. And I can go ahead and double check this again because I see that this is what kind of quadratic function? It's a positive quadratic function, which means I should have a happy graph. All right, try that last one on your own. Pause the video here now. Once you have given it a shot, unpause the video and we'll see how you did. All right, hopefully you paused the video long enough to check it out. The first thing I'm going to notice is that this is a negative quadratic function, meaning that it's going to be a negative graph. It's going to go down. Now I'm going to check that vertex, -b/2a. I notice that when I try to plug in b, there's no linear term, so it's technically just 0 on top. All over 2 times -1. Obviously still going to be 0. So when I make my table, I put 0 right in the middle, still go -1, -2, still go +1, +2, and then let's start throwing in values. When I plug in 0, I get -4. When I plug in -1, I get -5. When I plug in -2, I get -8. So let's go over and put that on the graph. I go to 0, -4, that's my vertex, meaning that the y-axis is my axis of symmetry, just as it was in the last problem. And then I go to -1, -5, -2, -8. All right, I'm going to do a little prediction and say that it's mirrored over the axis of symmetry. And when I go back and plug things in, I get 1 squared times a negative is -1, -4 minus 1 is -5, and same thing happens with +2. So my graph looks like this. And you can see that it did end up sloping downwards, meaning that it is a negative quadratic, and we did it correctly. All right, go try your homework. Let me know if you have any questions.